to start off by thanking her for all of her contributions to this. So my name is Erin Moore.
I'm Alex Kuczyaski.
I'm Lily McBroom.
I'm Arianna.
I'm Erin Adams.
And I'm Ella Floyd.
And this is establishing dose-response functions for licking oral nicotine and 6-MN by male and female rats.
So nicotine is a psychoactive component of tobacco products, and its ability to stimulate brain reward areas makes it a highly addictive substance. In rodents, stopping drug taking after chronic use has led to withdrawal as well as increased acceptance of nicotine's bitter taste. Adolescents are also potentially more susceptible to nicotine addiction due to their hyperactive reward system, and previous research has shown that it takes less nicotine to produce reward-related behaviors in adolescent rodents compared to adults.
Additionally, adolescent rodents are more plastic than our adults, which means that they're more susceptible to long-term changes in behavior and physiology. Previous research has shown that early life exposure to artificial sweeteners not only increases later licking avidity for sweet substances, but it also later increases tolerance to bitter substances. This is important to think about when we are considering what's going on in the nicotine industry currently. New routes of administration like vapes and oral pouches are a lot more favored by adolescents than they are by adults, and they're more accessible. As well, these products don't have intense FDA regulation, so companies can add chemicals to them without oversight. One common one is called 6-MN. It's a nicotine analog that is very similar both in chemical structure and in behavioral effect, and people add this chemical to these products to increase their potency without exceeding legal nicotine limits.
So given that early life experience can lead to chronic changes on reward behavior and physiology, it's important to understand if nicotine and 6-MN, which act on our reward systems, can also produce these chronic changes. However, this question cannot be currently answered as there's no established dose of nicotine and 6-MN that is known to elicit these changes. Which brings us to our present study. Our aim was to establish the first dose-response curve for oral nicotine and 6-MN. And if you look at this graph, this is our predicted dose-response curve. On the y-axis, we have our lick ratio, and on the x-axis, we have our concentration. And so basically what we were predicting is that as concentration increases, because nicotine and 6-MN are known to be bitter, licking behavior would decrease, giving us that curve.
In order to generate a dose-response curve, we used a method commonly used in behavioral neuroscience known as a brief axis test. And this was done in a specialized machine known as a Davis rig, which consists of a plastic chamber, bottles with spouts, and a chamber and a shutter to separate trials. There were various solutions presented in each one of these bottles, and each trial was separated by an electronic shutter. Once a rat initially began to lick a bottle, that would initiate the beginning of the trial, which would last for 10 seconds, and then a shutter would end the trial. Each session lasted for 30 minutes, and total licks to each concentration was recorded as a behavioral measure to each one of these substances.
It was hypothesized that both nicotine and 6-MN would elicit concentration dependency in such a way that as concentrations increase, licks would decrease. It was further hypothesized that the dose-response curve for 6-MN would be steeper and shifted to the left compared to nicotine because previous research has shown 6-MN to be more bitter and have better binding affinity than nicotine, which would elicit lower licks.
This study utilized 8 Sprague Dawley rats. All of them were adults, and they were maintained under standard care. And to make the groups even, we used a random counterbalance design where one group would start with nicotine and then move to 6-MN later, and then vice versa for those that started with 6-MN.
So our experiment included 4 phases. The first phase included low doses of nicotine and 6-MN that had previously elicited ingestive and aversive responses in a taste reactivity test. However, due to obvious lack of concentration dependency, we switched to phase 2 where we increased the concentrations of both. The nicotine concentration was based off of place preference, and the second concentration of 6-MN, as a result of a lack of research done on 6-MN, we just used the highest concentration possible for our stock solution.
And then due to the continued lack of concentration-dependent licking behaviors, we implemented phase 3, which was our quinine phase. We did this to really just to make sure that the animals could produce concentration-dependent licking behavior, to make sure there was nothing with their taste reactivity that was confounding our study. And we used quinine because quinine is known to be bitter. And we did see concentration-dependent licking behavior, so we moved into phase 4, which was our higher and broader range of nicotine. And we only did nicotine during this phase just due to the limited time and the number of sessions that needed to be ran.
So prior to actually testing the rodents with the drugs, we wanted to get them familiar with the Davis rig. So we had a week of water training. This started with 2 stationary sessions where they had access to the water without the shutter there, so they could just lick from the spout and figure out where it was. And then on the second 2 days, they started doing active trials with the water where they had to choose to initiate licking with the shutter opening and closing. During all of this, they did not have access to water except for during those 30-minute sessions, and that continued into our drug testing. So during this time, Mondays remained a water training day just so that the animals didn't lose familiarity with the rigs. And then Wednesdays and Fridays were our drug testing sessions where they had 30-minute sessions. And again, this was their only access to water during those days. On Tuesdays and Thursdays, since we didn't test them, we gave them 30 minutes of water access in their home cages rather than in the rigs.
So data were compiled across sessions in order to identify the average number of licks to each concentration of each substance, as well as the average number of licks to water. And then we used those numbers to do the formula on the right, which generated us a lick ratio. A lick ratio of 1 would indicate that the rats lick the substance more than water. A lick ratio of 1 would indicate that the rats lick the substance the same as water. And a lick ratio of less than 1 would indicate that the rats lick the substance less than water. 2x5 ANOVA was utilized to examine for statistical significance.
So for all of the following graphs, the dosage and concentration will be presented on the x-axis and the lick ratio will be presented on the y-axis. After visual observation of a lack of concentration dependency, no statistical analyses were performed for low doses of nicotine or 6-MN. However, those data are visualized in this graph.
These show the dose response curves for both nicotine, which is on the left, and 6-MN, which is on the right, for our mid-range of phase 2. There were no significant variables for these either, which just meant that as concentration increased, nothing changed with behaviors.
Due to insignificant findings for low and mid-range nicotine and 6-MN, we decided to run an array of quinine concentrations, and a 2x5 ANOVA revealed that there was a significant main effective concentration, meaning that as dosage increased, licking behaviors decreased. This significant finding also allowed us to rule out any possible issues with our experiments.
Because we did find concentration-dependent results from quinine, we decided to run a higher and broader range of nicotine solutions to see if our rats were even sensitive to the bitterants in nicotine itself. And as you can see on the left, we did find a main effect of concentration in that as nicotine concentration increased, licking behaviors decreased. Additionally, as seen on the right, males are in the red line and females are in the purple line. There was a significant main effect of sex in that males licked more avidly for nicotine overall than did females. We did not find any significant interactions.
So overall, the low to mid-range concentrations of 6-MN and nicotine did not produce concentration-dependent licking patterns. However, the concentrations of quinine and the larger ranges of high concentration of nicotine did establish concentration-dependent licking.
So one potential limitation for a study would be methodological differences between us and previous literature. Previous literature has found aversive responses to nicotine in the low series concentrations. However, they used a method called a taste reactivity test, which may have more efficiently activated bitter taste receptors on the tongue. Well, we used a brief axis test.
Additionally, adult animals may have decreased bitter sensitivity or compared to adolescents, and we tend to think of bitterants as like, oh, this is just this really gross flavor, but there are a lot of different bitterants that act on different receptors, so it's possible that the bitterant that is in nicotine was not sensitive in these animals' age.
And then the final limitation is just that we could not get our animals to take enough trials, which left us with an inadequate amount of data to actually analyze. We are considering that maybe if we had a little bit more time to gather more trials, we could have seen some concentration dependency with the low and the mid concentrations.
So despite these limitations, it is crucial to continue in this vein of research. Future studies should test slightly lower but broader concentrations of both nicotine and 6-MN. And further, future studies should test these same doses and concentrations in younger rats to ensure that there is no age-related sensitivity issues. And lastly, early life chronic use of these substances should be assessed.
In conclusion, there is still much research to be done in the field of nicotine and 6-MN and the chronic changes that it can implement. However, this research was still important in assessing the risk factors that adolescents face when they're exposed to these substances. Thank you. We will now take any questions.